Okay, guys, so we're going to have to go the old route that I originally started doing because I'm at home working on this because the Wi-Fi at the school doesn't work. And so I tried to use my Wi-Fi at home, but now I'm on my school computer and it has a firewall, and I don't know what that means, and it's a big old mess. So we're going back to the old way. All right, so we're on page 85. This is SAS 2. So I am going to go over to where we need to be. All right, we are right here. All right, so we're talking about polynomials, okay? So a polynomial is just really an equation. So you can have a binomial, you can have a trinomial, you can have a 4th degree polynomial, you can have a 5th degree polynomial, you can have a 100th degree polynomial. So the example that it's showing right here is a quadratic function. Okay, it has a highest power of 2. So it says the quadratic function models the height of the firework would represent to time. So if you watch the video again, hit play. As the firework is going up, you see that our quadratic function is going up. It hits its max height, firework explodes, and it comes right back to where we started at the end. Okay, so it fits the form of the polynomial function. So on number 2, let me get my pen if I know how to remember how to do this way. Okay. It says consider the quadratic function h of t equals negative 16t squared plus 150t plus 5. All right. So up here at the top, it tells us that the number an in this long function, which is the equation for a polynomial, is called the leading coefficient. So in this case, our leading coefficient is negative 16. Okay? The leading coefficient goes with what's leading. If you're in the line of something, you're leading, you're the leader, so you're first in line. All right, then it talks about the number A0 is called the constant term. So the constant term in h of t is 5, and we know that is a constant because it does not have a letter attached. Okay? And then the integer n is called the degree of the polynomial, or also known as the power. So you will see the degree is 2. Okay? So an right here is my leading coefficient. The integer n is my degree, and my A0 is constant. So if you look at this equation, you notice that it has n minus 1. So last week, I believe, 2 weeks ago, sometime, we learned n minus 1 was the recursive definition. So you see how in this equation, we started with a t squared right here. Then we went to just a t, and then we went to no t. So we always want to start with our highest power and work our way down, which is why it is subtracting 1 each time. Okay. Let's see. Let me hit this. All right. Consider the quadratic function. It gives you the function. What is the degree? We just said the degree was 2. What is the value of the leading coefficient? Well, we said that was negative 16, and our constant term is 5. On number 3, it says, can a linear function also be considered a polynomial function? Why or why not? So we know that a linear function is in slope-intercept form, okay, with m being our slope and b being our y-intercept. So if I give you the example, y equals 4x plus 2. What is the degree on this x? It's something we don't have to write, but we just kind of know it's there. A 1, right? So, can a linear function also be considered a polynomial function? Yes, it most definitely can, because a linear function can be written in this form with first degree polynomial functions. So, linear functions are first degree polynomial function. Okay? This just tells us that the first term cannot equal 0. If the first term was 0, then it would just be a constant, and that would not be a polynomial. It would just simply be a number. Okay? Alright, on number 4, we're simply combining like terms. Okay, so the first one, 7x squared minus 14x plus 25 plus, and you always want to line up your like terms. All right, so then I have 25 minus 4, which is a positive 21. I have negative 14x plus 3x, which is negative 11x. And last but not least, I have 7x squared plus 3x squared, which is 10x squared. Okay? So I'm just combining like terms there, just simply adding or subtracting. So there's the work we did. We get the same answer. So now what I want you to do, I want you to do B on your own. You're just adding again. So I want you to do B on your own. Once you're done, you can hit the check button and it'll tell you and show you the correct way to do it. All right. Let's see. There it goes. Number 5. All right, on Agile Mind, it says, when creating the square footage of a house for resale, real estate agents do not figure in any area that is not heated or cooled, such as garages, patios, or covered porches. Suppose the total square footage of a house is represented by the expression 35x squared plus 20x minus 56 feet squared. And it's feet squared because you're finding the total square footage, which is the area. And area is length times width, so that means it'll be squared. But this expression includes the garage space of 2x squared minus x plus 21. Now, before we do anything else, in the first sentence, it says, real estate agents do not figure in any area that is not heated or cooled, such as garages, patios, or covered porches. All right, but right here, it tells us this expression includes garage space of this. The question is, what square footage will the real estate agent list on the house appraisal sheet? So if we know the real estate agent does not want the garage on there, but we know the total has the garage, what should we do with the garage space? Well, we should subtract it. All right, so unlike adding, we have to distribute this negative to every term because the negative is on the outside of my parentheses. So that means this becomes a negative 2. A negative times a negative makes a positive. And then this will become negative. So now we just solve. 35x squared minus 2x squared is 33x squared. 20x plus 1x is 21x. And negative 56 minus 21 is negative 77. And this is feet squared. Okay, so now I want to check our answer. So they did the same thing that we did. Look, they even said important. Remember to distribute the subtraction sign to every term in the second polynomial. Okay, cannot forget that. Let's see. What number are we on now? 6. Yes, we're on number 6. All right, so number 6, we are subtracting. So we have to change our sign on the second set of the parentheses. So first, we have 4x cubed minus x squared plus 5x minus 9 minus 5x. Oh, look, I almost did not line them up correctly. You have to line your powers up. All right. There's my setup. So now I have to take this negative sign and change every sign next to it. So this becomes a negative 5, this becomes a positive 8, and this becomes a positive 7. So now we say negative 9 plus 7 is a negative 2. 5x plus 13x, I gave the answer. 5x plus 8x is a positive 13x. A negative x squared minus a 5x squared is a negative 6x squared. And since we don't have anything for 4x squared, we are simply just bringing it down to be 4x cubed. This will be my answer. So now I'm going to check. And this right here is showing me my answer. So now I want you to do B, but on this time you are just adding them. So you want to line up your terms and you want to combine like terms and you want to add. Now, number 7 is kind of tricky, I think. So it says on number 7, if you add polynomial expressions together, will the sum always be polynomial expressions? Okay, so this is for adding. If I have x plus 4 and I have x plus 5 and I add them together, okay? An x plus an x is a 2x. 4 plus 5 is 9. Is that still a polynomial? Yes, it has a degree. Has a degree of 1. Okay? But for subtracting, let's say we're going to use the same examples. X plus 4 minus x plus 5. So now I have x plus 4, and I've got to distribute this negative to both terms, minus x minus 5. Well, what happens to these x's? Well, they cancel, and I'm just left with 4 minus 5, which gives me negative 1. And that is not a polynomial. That is just a constant. So, in conclusion, when you're adding, yes, you will always have a polynomial. When you're subtracting, no, you might not always have a polynomial. Okay? All right, number 8. It says, you've seen that adding and subtracting polynomial expressions results in new polynomial expressions. Do you think multiplying two polynomial expressions will result in a new polynomial? Try multiplying two linear expressions written as binomials. So those are binomials because they have two terms, okay? Oh, it says it next. As you recall, are expressions with two terms. You can use the distributive property to multiply these two binomials as you see in this animation. So I'm going to hit play first. And it's going to show you a different approach than what I'm going to show you. Alright, that's how Agile Mind teaches you. Here's how Miss Ellery teaches you. So we got the box. We are multiplying 3x minus 2 and 2x plus 2. So on top, we are writing a 3x minus 2. On our side, we're saying 2x plus 2. Now, remember, everything on the outside, we multiply. Everything on the inside, we combine. So, a 3x times a 2x is a 6x squared. Okay? A 3x times a 2 is just a 6x. A negative 2 times a 2x is a negative 4x. And a negative 2 times a positive 2 is a negative 4. So we have 6x squared minus 4x plus 6x minus 4. Now, since I don't have any other x squared terms, I'm going to go ahead and say 6x squared. I've used it. Now, I can combine negative 4 and positive 6, which gives me a positive 2x, and then my constant is a negative 4. Their answer and my answer is the same. Either approach you take is totally fine. All right, let's see. So I want you to do on your own all of number 9. It's the reinforce. I'll go to it so you can see what I'm talking about. I want you to do all of number 9. I want you to do 10A and 10B and 10D. I'm going to go over C with you right now. That way you know how to do D. Okay? So, all right. So you notice that C has 1, 2, 3 set of parentheses, whereas A and B only have 2. All right, so here's how you do something with 3. You simply pick 2 to start with. I always do the first 2. It's just the easiest, okay? So I'm multiplying these first 2 first, okay? Up top, I have an x plus 1. On the side, I have an x minus 1. I have an x squared. I have an x. I have a negative x. And I have a negative 1. Now, we are left with x squared minus 1 because these cancel out. Okay? So now, this equals x squared minus 1. So all I'm going to do is simply bring down x plus 3. Okay? Now what I'm going to do is the exact same thing. Except this time up top, oh man, I have an x squared minus 1 and an x plus 3. So now an x squared times an x is an x cubed. An x squared times 3 is 3x squared. An x times a negative 1 is a negative x. And a positive 3 times a negative 1 is a negative 3. So you always want to write your answer with the highest power being first. Our highest power is x cubed. Then I want to work my way down. Plus 3x squared minus x minus 3. Okay? So remember, you're doing all of 9, 10A, B, and D on your own for practice.